Alright, so moving on to solving quadratics. Notice that the difference here between these quadratics that I'm solving and the ones that we were looking at up above is that down here in the solving quadratics, I have an equal sign between the sides. So what I'm really looking for when I solve a quadratic is what x values allow me to find a solution where this expression is true. So let's take a look. The first thing we want to do is we want to move everything to one side. So I'm going to, with this x squared plus 32x equals 12x, I'm going to subtract 12x from both sides, and I'm going to get an x squared minus 12x plus 32 equals 0. All right. And now what I'm going to do is I'm going to go ahead and factor, because I can use factoring as a tool here. So what I'm looking for, again, remember, I want two numbers that multiply to be a positive 32 that add up to be a negative 12. And so I'm looking at 1 times 32, either positive, both positive or both negative. That one does not, most definitely does not add up to 12. Let's see, my next one would be 2 times my 16. Again, that adds to 18 or negative 18. Not divisible by 3, 32 isn't. So I get 4 times 8. Oh, look, we changed colors. Well, 4 plus 8 is 12. So if they were both negative, like this, then I would be good to go, right? Because negative 4 plus negative 8 is equal to negative 12. So what I'm going to end up with here is an x minus a 4 times an x minus an 8 equals 0. Now, what I'm looking at is if this term right here, if it's equal to 0, then 0 times anything, this is anything, equals 0. So if x minus 4 equals 0, then I have one solution. Oops, it's supposed to be a minus, equals 0. And my other solution happens because if this is equal to 0, the x minus 8 is equal to 0, then 0 times anything, whatever this is going to be 0. And so I have x minus 8 equal to 0. So I'm going to bring those over here. That means that if I move the 4 to the other side and solve, I get x equal to 4 and x equal to 8. So these are my two solutions. Now keep an eye out on the notation that it wants, because if I just want to write like x equal to 4 comma 8 or something like that, that's great. If it asks for an interval, or not an interval, in a set notation, then we would write 4, there's a bracket there, and comma 8. All right, so this would be another way. So we've got two ways there. The second one there is called interval notation. Let's take a look at the second one. Again, if any pieces of these, you notice this one's factored. It's not necessarily just a quadratic. It's got a lot going on. There's several different quadratics hanging out, plus an x. So at any rate, this factored thing, if this right here, the first term is equal to 0, then the whole thing's equal to 0. If this term, the 4x plus 5, is equal to 0, then I would have 0 squared, and then I'd multiply it by whatever the rest of it is, and that would be equal to 0. Or, let's see, if this last x squared minus 64 equals 0, then the whole thing equals 0, right? So I'm going to say x equal to 0. That's one of mine. That's coming off of this yellow one right here. That's actually my solution there from that one. My next one is then, or 4x plus 5 equals 0. Right? Or my x squared minus 64 equals 0 is what I know. So if I look at the middle one, the purple one there, and continue down, I'm going to move the 5 to the other side. So subtract 5 from both sides. I get 4x equals negative 5, and x equals negative 5 over 4. All right, so that's my second solution here. The last one here, the x squared minus 64, my kind of aqua color there. For that one, what I have is I could either factor that. That's a beautiful difference of squares, right? Or what we could do is we can actually move it to the other side, move the 64 to the other side, and square root both sides. But we have to be a little careful. So let's go that route. So I get an x squared equals 64. I added 64 to both sides. I'm going to square root both sides. So I'm square rooting this side. That was positive to start with. This side, I need to do both positive and negative solutions for this, because when I take this square root here, what I'm going to get is x is equal to either plus or minus 8, right? Because that's the square root of 64. That's because negative 8 squared is equal to 64, and 8 squared is also equal to 64. So that's one set of options for my solutions. Again, if you wanted to do interval notation, I tend to like to write them in ascending order from smallest to greatest. So negative 8 and negative 5 over 4, 0, and 8. Those would be my solutions in interval, or in set notation, sorry. I really want an interval notation, apparently. All good? So keep an eye on the instructions and what they want it written as, so that it doesn't mark you wrong. All right, the next one, distance formula in simplifying radicals. Here I want to find the distance between the point at negative 4, negative 2, and at negative 6, negative 6. So I'm going to say this is x1, y1, and this is some point x2, y2. And I know from my distance formula that d is equal to the square root of my y, let's start with the x, of x2 minus x1, that's the displacement in the x direction, squared, plus y2 minus y1, that's my y displacement, squared, all square rooted. And we're using basically a version of the Pythagorean theorem here. So, subbing in, I'm going to get, let's go ahead and do that part, I'm going to get a negative 6 minus, let's do this way, negative 6 minus a negative 4 squared, plus, don't forget all these parentheses, a negative 6 minus a negative 2 squared. That's my y. And bring this across. All right, so keep an eye on those negatives. These two turn into a positive. These two turn into a positive. And so what I get is the square root of a negative 6 plus a 4 is a negative 2 squared, plus, and negative 6 plus 2 is a negative 4 squared. Right? Be sure when you punch these into your calculator, you keep those parentheses. Remember, negative 2 squared is negative 2 times negative 2. So it's going to be a positive number, a 4. Okay, so I'm going to get a 4 plus a 16. That's going to be equal to the square root of 20. Now this can be reduced, so don't stop quite yet. That's equal to the square root of 4 times 5. That's not a point here. Let me fix this. Times 5. And I can actually square root the 4. So remember, we can take this outside of the square root as a 2. And so then I end up with 2 square root of 5. And we're done. That's the distance between the point negative 4, negative 2, and negative 6, and negative 6. All right? All right. Let's take a look at domain and range. Remember, domain here is the possible inputs. Or x values, if you want to think about it that way. Okay, they're the possible values of our independent variable. I like to think of them as our inputs or our x values. Things we're looking for here. One of the things is if we have a fraction, we can't divide by a 0, right? So the denominator can't be a 0. If we have a square root, the square root argument, the thing inside the square root, it has to be greater than or equal to 0. It can't be negative. We don't do a lot of logs in this class, but if I was looking at logs, then the log would have, whatever the argument is there, whatever's inside the log, would have to be greater than 0. It can't even be equal to 0. So keep an eye out for those crazy functions. Also with the square root one, that applies to any even root. The odd roots I don't have an issue with. Those are going to be a domain of negative infinity to infinity. All right. So if we look at this first one here, f of x is equal to 2x minus 4. What I notice is that there's no fraction, there's no square root, there's no log. It's really just a line. And so it keeps going for all reals. So I'm going to have a domain of negative infinity to infinity. All right. This right here is interval notation, which I really wanted to have earlier. Or wanted to say earlier anyway. All right, so this is my interval notation for this one. Any polynomial like this, whether I have a 2x minus 4, a 5x squared, plus a 3x minus a 5, also negative infinity to infinity, an x to the 67th minus a 5x to the 66th, so on all the way down, still negative infinity to infinity. All right, so all reals. On the second one here, what I'm keying off of is I don't have any concern with the roots, but I do have a number down in the denominator. So I'm going to take a look at that because what I know is that x squared cannot equal 0. Okay? If I square root both sides, I get that x is not equal to 0. So if you're writing this as just an inequality in an answer, that's how I could write it, is x not equal to 0 because I can't divide by 0. If you want to write it in interval notation, I would say I go from negative infinity all the way up to 0, but not including it, so parentheses, union with a parentheses 0 to infinity. That means I'm just excluding the 0. Remember, the parentheses means the end point is not included, and a bracket there would mean that it is. Now let's take a look at the bracket. Number 3, f of x is equal to the square root of 2x minus 4. So here what we want is we want this argument, the thing inside the square root. It has to be equal to or greater than 0. It can't be negative because I can't take the square root of a negative number. If you're not sure you believe me, go and try it on your calculator. All right? So what I want is that 2x minus 4 has to be greater than or equal to 0. If I add 4 to both sides, I get that 2x is greater than or equal to 4. And dividing both sides by 2, I get that x is greater than or equal to 2. This would be my inequality answer. If I want my interval answer, I'm going to go from 2. It's got to be greater than it. X is greater than that. All the way up to infinity. The infinity always has a parentheses. Since I can be equal to 2, I'm going to use that bracket there next to the 2. So this right here is my interval notation. Okay? Perfect. Hopefully those make sense now. Let's take a look at finding the domain and range of the graphed function. So over here I have a graph. Remember, domain is my x values, my inputs. That's always the x-axis. My range is my outputs, so my y values. What are my potential y values? All right. So if I go over here, if I'm looking for my domain, I can see that I'm going from this point right here at negative 4 all the way up to this point at x equals 4. Both of them are closed dots, so I'm going to say I have a domain from negative 4 to 4. Both of them are brackets because those are included. If they were open circles, they would be parentheses because they're not included. All right? My range. I'm looking at my absolutely smallest y value, and that's at 0, right? So down here at 0. And my max, I'll put a pink dot on it, is right up here, all right? And that's at 6. It's included because there's no hole up there. So I'm going to say to 6, and I'm going to close the bracket. Okay? Again, if there was a hole up there, I would use a parentheses. Hopefully that makes sense. All right. Let's talk about the vertical line test. We use the vertical line test to determine is it a function? Remember, what a function is for every input, I can have at most one output. I could have none, but I have to have at most one. So the vertical line test tells me that if there's any point at all on the curve where I draw a vertical line and it crosses that curve more than once, then it's not a function. So if I look, let's say, let's do it in pink. If I look at this one right here, I draw a vertical line that's up and down. So no matter where I move this to, I'm only crossing that line, is what it really is, once. So this is, yes, it is a function. If I go over to the other one, let me take my vertical line with me, you can see that I have multiple places where I cross that vertical line with my curve more than once. And so this one is not a function. No, not a function. All right, that's my vertical line test. So hopefully you remember the functions in that. Exponent rules and rationalizing the denominator. So over here we have a few exponent rules. Remember, if I have a to the m times a to the n, I'm going to add those two exponents. If I have a to the m divided by a to the n, I'm going to subtract them. A to the negative n is equal to 1 over a to the n. And 1 over a to the negative n is equal to a to the n. We have the nested exponents there, where I have the a to the m all to the n power, then I multiply those exponents. Again, I can separate it and kind of distribute the exponent into each term in the next one, so I get an a to the m right here, and a b to the m right here. I'm doing the same thing in the next one, just with a fraction. If I have an a to the negative m, an a over b to the negative m, I can flip that fraction. Notice what happened between here and here. And then you can distribute into each of these. All right. Other common things we see, a to the first power is just equal to a. It just means I've got one of them, and a to the 0th power equals 1. That goes for any a's. All right, so let's take a look. What I'm going to do first is I'm going to distribute this negative 2 in to everything in the numerator. And so I'm going to say that I have, well, we don't really need the parentheses anymore. Okay, a to the 0 times negative 2 is still going to be an a to the 0. My b becomes a b to the negative 2 times negative 2, so that's going to be a 4. And then I have a b to the 5 times negative 2, negative 10. In the denominator, I have a 2 to the negative 2, right? I have an a, so I'm doing the bottom part now. Right here, and right here. So I'm going to have an a to the negative 1 times negative 2, so an a squared, and a b to the negative 6. I know I changed colors halfway through. So let's clean this up. The first thing I notice is I have an a to the 0. This turns into a 1, right? All right. Oh, well, we'll change colors. This 2 to the, I'm going to deal with this 2 to the negative 2. That's going to make this go up on top. So I'm going to get a 2 squared, all right? These two put together, notice what I'm going to do is use that very top one, so I'm going to add those exponents. So I'm going to get a b to the negative 6, because I have a 4 plus a negative 10. I have my a squared. I already took care of the 2 to the negative 2. And I have a b, yeah, okay, a b to the, sorry, my brain worked a little, negative 6. So I see that I have a common b to the negative 6. So those are going to cross out. And now what I'm going to have is 2 squared is 4 over an a squared. And that's simplified with no negative exponents, so I'm all good. All right. The next example wants us to rationalize. What that means is I don't want a square root in the denominator. So what I'm going to do is I'm going to multiply both the numerator and denominator by the same thing, and I'm going to multiply by the square root of 5 and the square root of 5. Those two square roots multiplied by each other gives me a 5 in the denominator, and in the numerator I get 10 square root of 5. Now don't stop quite yet, because we can reduce, right? This 10 is divisible by 5, so I get a 2, and this turns into a 1. And so I get a 2 square root of 5 as my answer here. Alright? Be sure to reduce when you do these. Common thing to forget to do. This one looks a little bit different. I'm trying to make it so you can still see that one. This one looks a little bit different. Here I have an 8 times an x minus y squared, and I have a square root of x minus the square root of y. With this one we use, if you remember, what we call the conjugate. Basically it's the same expression as I have in the denominator, except I'm going to use a plus sign in between it. The square root of x plus the square root of y. Remember, I got to multiply numerator and denominator by the same thing. So what I'm going to have is I'm going to have an 8 times my x minus y squared times, remember there's parentheses around this, so we're kind of foiling the denominator, and that's why this works. I get the square root of x plus the square root of y, and then down here in the denominator, when you do for firsts, you're going to have an x. When you do your inners, you're going to have minus the square root of x times the square root of y. And when you do your outers, you're going to have plus the square root of x times the square root of y. So those inner and outers are going to cancel. And I'm just going to come out with minus a square root of y squared. I don't know where that came from, which is going to just be a y. All right. Now I notice that this right here in the denominator is the same as one of these up here. So I'm going to cross out one of those. So I'm going to leave one up here and none up down in the denominator. And so I'm going to have 8 times an x minus y times the square root of x plus the square root of y. And that's going to be my answer there. I've rationalized the denominator and taken care of it. All right? Hopefully that helps. I'm going to do one more video on adding and subtracting rational functions expressions, just because there's a couple of other things here and then some lines issue that we want to look at. So I'm going to stop it here because we're at about 17 or 18 minutes, and we'll do one more on algebra. All right? I'll see you soon.